Can you see my screen?
Yes, ma'am.
Okay. Okay, let's start. So here we are having few properties of adjoint, and this was also there in class 12. Okay. We will be solving one question by using these properties, and then we will move ahead and we will see okay, let's see what will be the next. First, let's take one question which is related to this properties. So just a moment. Okay, so our first question is, let A be a 3 cross 3 real matrix if determinant of 2 adjoint, then again 2 times adjoint of 2A, yeah, is equals to 2 to the power 41. Then the value of determinant of A square equal options are given over here: 9, 4, 8, none of these. Okay, so let's see how to solve this question. So we are having this condition. Okay, by using this condition, we have to find determinant of A square. We are having this condition in hand. Okay, left hand side we are having, right hand side also value is given. By using this condition, we have to find the value of determinant of A square. So how we will be doing so? So let's write it. We are having this one in hand, determinant of 2 times adjoint, then again adjoint, 2 adjoint, then one more time, twice A, is equals to 2 to the power 41. Let me check whether all the adjoints over here I have written properly or not. So it's 2 adjoint, then again 2 adjoint, then again, okay, I'm missing one adjoint over here. Okay, here one bracket is there, and then again a joint is there. Yeah, and then 2A is there, bracket closed, one bracket, 4 brackets are there. Let me write it carefully over here. So it's determinant of 2 adjoint, then again 2 times adjoint, then again adjoint of 2A, bracket close, one more bracket, one more and one more. Yeah, that is equals to 2 to the power 41. And we have to find the value of determinant of A square. Yeah, determinant of A square. This is what we have to find. Let's do it by using the property, obviously. So what we will do over here, outside this determinant is there, it's okay. First, we will try to simplify this part. Okay, so let's see what can be done over here. Here, if we will see the most inside part, here we are having a joint of 2A, and we are having one property. Let's see. These are the properties which we are having. Okay, you are already aware of all the properties, right? If not, then please write it. So these are the properties we are having in hand. If I am saying that we will be focusing on a joint of 2A, then it looks like this one, a joint of Ka. K is a scalar. So a joint of K times A is equals to K to the power n minus 1, a joint of A. Let's use this property. It says K to the power n minus 1 and then adjoint A. So let's write it. This one will be K is 2. So 2 to the power n minus 1. What is n? So AB 3 cross 3 real matrix. So 3 n minus 1, K to the power n minus 1 adjoint A. That's what was written over there, right? It was like that, this only. Can you see the property over here? Let's move ahead. So rest of the terms as it is, we are having 2 adjoint over here, then 2 adjoint over here. Okay, that's it. So we are having this. Outside determinant is there, and on the other side 2 to the power 41 is there. We will be taking that. Let's solve it quickly, the left hand side part. So here we will be having 2 to the power 3 minus 1, that means 2 square, that means 4. So 4 adjoint A we are having, and here also 2 adjoint, here also 2 adjoint. Okay, so 1 2, yeah, this is what we are having in our hand. Is it clear so far? Is it clear so far what we have done over here? Let me know. Can we move ahead? Yes or no? Can we move ahead?
Yes, ma'am.
Now we are having, okay, now we are having, again, if we will focus, a joint of, we can say this is K and this is A. Again, that type of arrangement we are having. Don't worry about this adjoint. We are going to treat it like A. So the property which we have applied in the previous step, the same property we are going to repeat it over here. Okay, let's see how. So adjoint of KA, adjoint of KA is K to the power n minus 1 adjoint. This property we are going to use over here. So determinant, just a minute. Determinant, let me say it again. So what? So we are having determinant, then 2 times adjoint, then again 2, and this adjoint of KA, we are going to use the formula for this part. Okay, adjoint of K into A, that way we are going to use the property. So the property says K to the power n minus 1. K is 4. So 4 to the power n minus 1 means 3 minus 1, that is 2. Okay, times adjoint A. So adjoint A. Now what we have taken as A, we have treated this adjoint A as A. So we have, wait, no, don't know what is happening again. Do you face such problem in other classes also? Yes or no? Let me know. Do you face such problem in other class also? So we have written 4 to the power 2, a joint of A. A is what? A is this. Is it clear so far? Let me know.
Yes,
2
ma'am.
times we have applied the same property. Okay. Now what are we having over here? We are having 2 adjoint. Here we are having 2 into 4, 4 times 16. That means 30. 16 2 times 32. Yeah. A joint of. Now can you see the same property again? We can apply. Can you see? adjoint of K into A. Yeah, we can apply the same property again. Let's apply it. So we can write determinant of 2, and here adjoint of K times A can be written as K to the power n minus 1. That means 32 to the power, or if this property will work or not, let me check. Okay, instead of that property, if we will apply this property, this one, property number 3, where adjoint of adjoint A is equals to determinant of A to the power n minus 2 A. Okay, let's use this property. Here we are having adjoint of adjoint A. Here we will be using determinant of A to the power n minus 2. N minus 2 means 3 minus 2, that is 1, times A. Okay, so what is our A? See here, adjoint of adjoint A is equals to this. So we will be having A over here. 32 is already there, nothing else will be there. Is it clear so far? Are you getting it? We are having here determinant of 64, then determinant A times A. Is it clear?
Yes, ma'am.
Now this 64 is just a number. This determinant of A is just a number. Okay, determinant of A will be just a value. The value can be anything. So we will treat, if we will treat the whole thing as a scalar, so are we having any property for determinant of A? Oh, just a moment, which property can be applied over here? Are we missing anything? Here we are having 2 times adjoint, again 2, and this one we have used the property, that is K to the power n minus 1 adjoint. Okay. Again, we are having 4 over here, adjoint A, here adjoint, here adjoint. How many times adjoint we were having in the question? 1, 2, 3. Yeah.
Excuse me, ma'am.
Yes, please.
Ma'am, we have not raised 32 to n minus 1. So 32 raised to 3 minus 1, 32 square.
Okay, here 32 to the power n minus 1, that means 3 minus 1 we have not written. That's what you are saying?
Yes, ma'am.
Yes, we will be taking that adjoint of this all together will be. Okay, yeah, one adjoint was here, which I have not taken in consideration. Let me wipe this part and let me write everything clearly. So this one, this will give the formula that determinant of A to the power n minus 1 times A. Check it. Okay, it's determinant of A to the power n minus 2. This formula we are using over here. Adjoint of adjoint A is equals to determinant of A to the power n minus 2 times A, not 1. So we will be taking this. N is 3 over here. For only this part I have written this formula. For only this purple part. Okay, this 32 will remain as it is. Outside 2 adjoint will remain as it is. This determinant we are having. Okay. Now let's see what we'll be having as a next step. So we will be having two adjoint here 32. Here determinant of a to the power 3 minus 2 is there. That will give us 1 into a is there. Okay. Outside this determinant is there. Now what we will be having? This determinant, then 2 adjoint and 32. Determinant of a to the power 1 is there, or only determinant a is there, we can say, into a is there. Now this we will just treat as a scalar k. Okay, so a joint of k times a, the formula which we have applied in the very beginning, that is a joint of k into a is equals to k to the power n minus 1 into a joint a. That formula again we will be applying, k to the power n minus 1 into a joint a. What is our k? So 32 determinant of a, everything's powers n minus 1, that means 3 minus 1 times adjoint a. Okay, so adjoint a. Outside this 2 was still there, this determinant still we are copy pasting in each and every step. So what we are having over here, we are having determinant of 2. Yes, you said it correctly, that we will be having 32 to the power 2 over here, and this determinant of a will also be square over here. And now this adjoint a formula we will be applying from the properties only. So let's see any formula which will give us determinant only. So which property we can apply? We are missing anything over here. Just a moment, no. Let me check the question. Are we missing anything? If on in the last step, in this step, we are having a joint of something. Okay, we will take this question just after a while, because we are running out of time. We have to discuss a lot of questions over here. I'll be taking it. Okay, again. Let me take another question for now. We are almost there, but we are missing something due to this much of brackets and everything. Okay, let me take another question. I'll come, at last I'll come to this question. So the next question is, okay, we will see how to apply elementary operation on determinants. Okay. Are we having any? This one we are taking as a k times a joint A. That's determinant. This determinant as a sign. Oh yeah. Do you know one property? That determinant of k times A can be written as k to the power n minus 1. Do you know that property? One property is there that whenever something is there inside the determinant, here we don't have that property. Do we have? Determinant of adjoint A is equals to determinant of A to the power n minus 1. This property can we apply over here? Can we? And we also have in front k, so that this one. Can we apply this property over here? We are having determinant of this all. Okay. So can we apply this property? We can write k to the power n minus 1. So 2 times 32 square times determinant A square. If we will take n minus 1, that means square. And determinant of adjoint A can be written as A to the power n minus 1. Determinants A, that's power 2. Yeah, that is equals to 2 to the power 41 is there. So what we will be having here? Here it's 2 square into 32 to the power 4 into determinant of A to the power 4 into determinant of A square. So 4 plus 2, 5, 6. Let me check. We will be having 2 to the power 5 here, and that 5 4 times 20, 21, 22. So all 2, if I will collect together, we will be having 2 to the power 22. Determinant of A to the power 6 is equals to 2 to the power 41. If we will subtract it from that side, okay, just a moment, I'll take it again. Elementary operation we will be discussing for determinants for now. Okay. Now how to apply elementary operation. Let me take one question and why we are going to learn this concept, that we will discuss over here. Just a second. Yeah. So if we are having this type of question, only we have to find the determinant over here. A plus 1, A plus 2. Then again A plus 2 over here. Then 1. Here we are having A plus 2, A plus 3. Here we are having A plus 3. And here we are having 1. Next one we are having A plus 3, A plus 4. After that we are having A plus 4 over here. Here we are having 1. Okay. And we have to find the value of the given determinant. Option A is given over here as A plus 2, A plus 3, A plus 4. Option 2 is given over here as minus 2. Option C is A plus 1, A plus 2, A plus 3. And option D is given over here as 0. Okay. So we just have to solve this determinant and we have to find the value. Now if you will just take the way you were doing in class 12, if you will just start doing it like this, it will take a lot of time. Okay, we have to do it quickly, and like this a lot of questions will be there. You can practice a lot of questions which where we will be applying the elementary operation, and which will save our time a lot. So for that only we are going to learn the elementary operation. So let's see how can we apply elementary operation. That will be useful over here also, and even if once you will get used to it, no, you will be able to apply it with numbers also easily. You will be able to just solve your determinants. So here what can be done, here we can see 1, here we can see 1, here we can see 1. Now in this determinant, if we will be able to make any two from one row or from one column, how we expand the determinant, we just pick any one of the row or any one of the column, and then accordingly we go ahead and we expand it. So here if we will be able to make any two element of a single row or maybe a single column 0, then easily we will be able to expand it by taking only the third element. So what I am trying to say, that if I will be able to make this one as a 0 and this one as a 0, and this even if it will remain 1 only, we will be able to just expand it quickly by using this one, because 0, what whenever we will multiply 0 with any other number, it will be 0. This will also give everything 0. So we will just pick this one, we will expand it, and we will be able to get our answer. So to solve the determinant quickly, we need to know a elementary operation. How we will be applying that? So what we can do here, we are having, we must know this is row, this is row 1, this is row 2, this is row 3. So what we can do here, you can do it your way, I am taking it, let's see how we can do it. So whatever way you are doing, maybe you are applying any other elementary operation, your friend is applying the other elementary operation, but at the end your answer, my answer, your friend's answer, everyone's answer has to be same. Okay, so let's apply elementary operation over here. So here we are having a plus 1, here we are having a plus 2 also. After that we are having a plus 2, and here we are having 1. Let me write it in a bigger way so that I can show you. Let's write for now as it is, and then in the next step I'll be writing it. A plus 2, a plus 3. Here we are having a plus 3 only, and here also we are having 1. In the last row we are having a plus 3, a plus 4, a plus 3, a plus 4. Then we are having a plus 4 over here, and here we'll be having 1. So what can we do? We can take row 1 dash, that means the new row 1, whatever we are going to make, that will be, that is equals to row 1 minus row 2. This is how, this is one of the way of doing it. Okay, so row 1 dash is equals to row 1 minus row 2. That's what we are going to do now. And also I am going to change row 2. So row 2 dash is equals to row 2 minus row 3. Why I am doing so? I said in the very beginning that we want to make two elements from the third column 0. Okay. So let's do it. So we are going to subtract row 1 minus row 2. So we are going to do the subtraction like this. Row 1 is a plus 1 over here. Here we are having a plus 1, a plus 2, row 1 element minus row 2 element. I'll be writing it over here only. Okay. Next one will be a plus 2, a plus 3 minus a plus 3, a plus 4. I am just subtracting this 2, this 2. Okay. The new row 1 I am writing over here, and the new row 2 I have written over here. The next one will be a plus 3, a plus 4. In the second column we will be doing the same thing. So a plus 2 is already there, minus a minus 3 we will be doing. Then a plus 3 was already there, minus a minus 4 we will be doing. Okay, the last row will remain as it is, because I have not written here that we are going to change row 3 also. Okay, here 1 minus 1 will become 0, 1 minus 1 will become 0, and the last row will become as it is. So this is what we are going to have over here. Is it clear so far how we are doing the subtraction and making the new row? Is it clear so far? Let me know. Now what we can do, in the first column we can see the first term a11, this one. We can see a plus 2 can be taken out as a common, and we will be having a plus 1 minus a minus 3. Yeah, this calculation we will be able to do quickly. This is the first question I have picked. That's why I am showing each and every steps over here. If this is not clear to you, please let me know. Is it clear so far? Here we can take out common a plus 3, and we will be having a plus 2 minus a minus 4. So basically what we are doing, let me repeat again if that is not clear to you. We are changing this row 1. How? We are changing and making it new row. How? By doing the subtraction of row 1 minus row 2. You can see this is what we have done over here. We are changing row 2 completely. How? By doing the subtraction row 2 minus row 3. Whatever is original row 2, from that we are subtracting row 3. And then we are getting a completely new row 2. Okay, that's what I have written over here. And then we just have to do the simplification. So we will be having these terms. The last will be as it is, a plus 3, a plus 4. Here in the second column, we will be having a gone, 2 minus 3 minus 1. A gone, 3 minus 4 negative 1. Here we'll be having a plus 4. The last column will be 0, 0, 1. Now I said to you why we are doing it, so that we can do the simplification. We can just expand the determinant easily. So here also I can see we will be getting 1 minus 3, that means negative 2. Here 2 minus 4, that means negative 2. Okay, so we are having negative 2 here, we are having negative 2 here. Nothing is here. Okay, this is what we are having for now. Now we will be expanding by taking this element. 0, 0, 1 is there. So this element we will pick and we will expand our determinant. Now we must know we must take the cofactor properly by taking the proper sign, that is plus sign or minus sign. So if you know this is plus, minus, plus, okay, then this is plus, then minus, then plus, then minus, then plus, then minus, then plus, minus, plus. So this is plus only, so we will be taking plus 1, we will be taking plus 1, and then we will cover this part we will cover, and this part we will cover. So what are we having? We are having minus 1 here, we are having minus 1 here, we are having this element here, we are having this element here. Crisscross multiplication we will do. So we will be having 2 times a plus 2, positive 2 times a plus 2, minus 2 times a plus 3. If we will take out 2 common out, we will be having a plus 2 minus a minus 3. This gone. We are having 2 minus 3, that is negative 1. We are having 2 outside, so minus 2 we got. Let's check whether this option is there or not. Can you see minus 2 is already there? Option B is the correct option. Have
Yes,
you
ma'am.
understood the process, how we are applying the elementary operation and how we are expanding it quickly by picking any row or any column? Let's take another question. So the next question we are having. Next question, we are having one of the question as a plus x is equals to b plus y is equals to c plus z plus 1, where a, b, c, z are non-zero real number. Then we have to find the determinant of this. X, y, z, a, b, c, plus y, plus y, x plus a, y plus b, z plus c. This is equals to, options are option A, y, b minus a, option B, y, a minus b, option C, 0, and option D, y, a minus c. Okay, let's do it. Again, we will see which property, like we will try applying the elementary operation. But before that, we will see whether that will be beneficial or not. One condition is given over here, that is a plus x is equals to b plus y is equals to c plus z plus 1. Now, whenever we can see this type of addition or subtraction between the element in our determinant, we can also write our determinant, the given determinant x, y, z. We are having x, a plus y, b plus y, c plus y, a plus y, b plus y, c plus y, and the last element we are having x plus a, y plus b, x plus a, x plus a, y plus b, and z plus c. That's what we are having here, z plus c. We can write it as, we can write this one as x, y, z, a plus y. For now, I am writing a plus y, b plus y, c plus y as it is. And the last column, I am going to break it in two determinants. Yes, that this is possible. We can do this. So what we can do, we can write this one as a x, this one y, this one z, plus x, y, z. This is also one of the property of determinant, that we can also break our determinant when there is addition or subtraction. Then we can break our determinant and we can write it in broken form like this. Let me know this step is clear to you or not, the second step. I have not done anything. The last column was x plus a, y plus b, z plus c. That's what I have just broken it and have written x, y, z in the first determinant, and a, b, c. In between plus sign I have written. If minus sign will be there, if it will be x minus a, y minus b, z minus c, then we will write minus sign and we will break our determinant like this only. Okay, so let's move ahead. Now there is a property of the determinant which says that when two column or two rows are exactly same, if it is exactly same, the determinant will come out as a 0. The result will come out as a 0. You can check it. Okay, you can check by doing the calculation. X will be taking here bz, yz here. When we will expand everything, the result will come out as a 0. Okay, so this exactly same two columns are there, that's why the result is 0. If exactly two same rows will be there, then also the result will be 0. Now we are left with only this part, that is x, y, z, a. Okay, let's expand it just like the previous one. So we can expand it like this, a, b, c, again a, b, c, plus x, y, z. We are expanding this, y, 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 a, b, c. Can you see again we ended up getting two exactly same columns? And can we say this result will also be 0? The previous result was also 0. So we are just left with this part, that is x, y, z, y, 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 a, b, c. Can you see it? Now what we will do, we will expand it. But here also we can apply our elementary operation. If you have practiced enough, easily you will be able to apply elementary operation. This y we can take common from here. We know from determinant, if we are taking out common, we can take out common from any one of the row or maybe any one of the column. That's how we take common from the determinant. In matrices, when we take something common out, any number, any scalar common out, that means we are taking from all the elements. But in determinant, we are focusing on one column on or one row. So if we are taking y column, it will be x, y, z, 1, 1, 1. Y I have taken out common from here, a, b, c. Okay, this is what we are getting from here. Now 1, 1, 1, if you can see here, elementary operation, again I can apply like the previous one. That is, or you can directly also expand. It's completely your choice. Okay, So row 1 dash will be row 1 minus row 2, the same operation, because I want to make this 0, and the last one will be as it is. Row 2 dash will be row 2 minus row 3. So outside y is there, it's okay. Inside we will be having x minus y minus z. We have to do the subtraction. Okay, the first row we are taking each and every element and we are subtracting it from the second rows. Each and every element, corresponding elements, we are subtracting. Okay, last one we are having z. Here we will be having 0 0 1. Here we'll be having a minus b minus c. Here we'll be having only c. Let's expand it by taking this one, because we can pick any one of the row or any one of the column and we can expand our determinant. Okay, by using the proper cofactor. So if we will expand it by taking this one, you can understand this is coming here. Negative sign we need to take. Okay, plus minus plus, then minus plus minus, then plus, then minus. So this negative one we need to take. That is the cofactor. Okay, before expanding it. We will cover this part. We will cover this part. We will be having, let's write it. Outside y is there, that's fine. Minus 1 we got. When we are going to expand it, we will be having x minus y. We will be having b minus c, y minus z. Now let's see the options. Options are y, b minus a minus b, a minus c, 0. Okay, y outside, we are also having y outside, but now we want to have b minus a minus b, a minus c, or maybe 0. 0 we are not getting. If you can see, once we will open the bracket, we are not getting 0. bx, by, cx, cy, ya. So 0 we will not be able to make. We have to use this condition which is given in the question. That is a plus x is equals to b plus y is equals to c plus z plus 1. So we are having the condition a plus x is equals to b plus y is equals to c plus z plus 1. Okay. Now y we are having outside, fine. Minus 1 also we are having outside. Okay. Now inside the bracket, curly bracket, x minus y. I want to write everything in terms of a and b, a, b, c. Okay. So x minus y, if we will use this two equation, this two uh, together, a plus x is equals to b plus y. If we will take this equation, so x minus y is equals to b minus a we can have. So we can have x minus y is equals to b minus a. Here we'll be having b minus c. Minus a minus b is there, all right. Y minus z is there. So if we will take this two together, so we will be having y minus z is equals to c plus 1 minus b. Okay. So we will be having c plus 1 minus b. Okay. Outside y is there. Now minus 1 is there, all right. B minus A is there. Here A minus B is there. So we will take out negative common from here and we will make it B minus A. So this will become positive. Okay. And now we will be taking B minus A common. So what we will be having? We will be having B minus C from the first part. And from the second part, we will be having plus C plus 1 minus B. This is what we'll be having, right? B gone, C gone. We are having plus 1 only. Okay. When we solve this, we got y multiplied with negative 1 multiplied with b minus a is there. And inside the bracket, nothing is there. Only plus 1 we got. That means plus 1 multiplied with b minus a is b minus a only. This is what we got. Let's see whether this option is there or not. So y b minus a, y a minus b. Negative sign is not there. That means we need to absorb this negative sign with the bracket. Okay. So we will be having a minus b y. So option B is the correct option. Can you see? Again, I would repeat what we have done here. We have first broken the given determinant. We can break it. When addition, subtraction, this type of element is there, then we can break the determinant and we can write it with addition sign or subtraction sign, whatever is given over there. Now, there is a property of the determinant. When two rows or two columns are exactly same, the result will be 0. So directly we are writing the result as a 0 and then we have applied the elementary operation. However, without applying the elementary operation also, you could have done from here, from this step, from this x, y, z, y, 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 a, b, c. It is possible to do by just by expanding usually the way you were doing in class 12. By using that knowledge only you can expand it, but yes, we need to use the given condition and then only we will be reaching at the given answer. Is it clear to everyone? Let me know.
Yes, ma'am.
Okay, now let's move ahead. Okay, one question is there. I'm giving a hint on this question because we need to all cover the system of equation, how to solve the system of equation by Cramer's rule. That also we'll be taking today only. So question is there, which is the maximum value of f of x is equals to sine square x 1 plus sine square x over here 1 plus cos square x. Here we are having cos square x. Here we are having cos square x. Here we are having cos 2x. Here we are having cos 2x. And here, now if you will look, see it carefully, can you see when we will add this first and second column and we will write it, then sine square x, cos square x, we will be getting in the first column. Like if we will add this, if we will make C1 dash the new column, that is the first column, will be column 1 plus column 2. Then in each and every, like the first element of the first column, the second element, the third element, here each and every element you will be getting as a sine square x, cos square x. Apart from that, other term will also be there, but you will be able to make the identity, that is sine square x plus cos square x, sine square x plus cos square x. Okay, so please use the elementary operation over here, solve this determinant, and then we will be finding the maximum value of the just obtain determinant. So what, when you will get the answer of this determinant after applying the elementary operation, the answer will be in the form of a cos theta plus b sin theta. Okay, so or a sin theta plus b cos theta. Let me write it proper way. We will be taking it like this in a standard form. That is, the answer you will obtain from here, from this determinant, will be in the form of a sin theta plus b cos theta. Now let me show you one result. Just a moment, just give me a second. Can you see my screen?
Yes, ma'am.
Here, if I would take, okay, where is the, just a moment. Yeah. If I would take sine 2x, can you see the maximum value is 1 and the minimum value is negative 1 over here? Can you see? Even if sine x lies between a negative 1 to positive 1, we know. But I am showing you that whenever if we are having instead of sine x, if we are having sine 2x, still the maximum value is 1 and the minimum value is -1. Can you see it? Yes or no? If we are having sine of, let's say 100x, still, okay, this is such a large number I have taken. Let me take a smaller number, 7x. Can you see the blue graph? Here, the maximum value on the y-axis, you just see on the y-axis. Okay, on the y-axis, the maximum value is 1 and the minimum value is -1, right? If I will take sine of 30 degree plus x, see the green graph. Let me remove the previous two. See this graph? Here the maximum value of y is 1 and the minimum value of y is -1. I'm just pointing it. You can check it. The maximum value of y is 1 and the minimum value of y is -1. So what you are getting from here, are you getting that if we are changing the inside function, if we are changing the angle, making it 2x, making it 3x, making it x plus pi by 4, making it x plus pi by 6, whatever we are doing with the angle, the output is still, it is lying between -1 to +1. What exactly is changing in the graph? The curve, this sinusoidal curve, sometimes it is compressing, sometimes it is stretching, but the output on the y-axis, it is going +1 to -1 only. Getting it? Are you getting it?
Yes, ma'am.
Yes, so that's what I wanted to show here. Then only we will be able to understand how to find the value over here. Okay, so when we are having a sine theta plus b cos theta, this type of arrangement, then we can say that we can write it in the form of, we can write it, let's say we are having a triangle, a right angle triangle. You can see my screen, right? Here we are having 90 degree, here we are having theta. Let's say this is A, this is B, then the hypotenuse will become under root A square plus B square, right? Now what will be the sine theta value? Sine theta will be, say this, sine theta will be A by under root A square plus B square, and cos theta will be B by under root A square plus B square. This is what we are getting from the triangle, which we have taken by ourselves only. I want to show you one result over here. So what we can do, we can multiply here under root A square plus B square. All together we can do the multiplication. So what we will be having, A by under root A square plus B square plus sine, let's take this sine x, because both theta, or you take this one as a phi, one as a theta. So this, if this is x, here we are having b by under root a square plus b square cos x. Okay, yes, whatever I have taken previously, the assumption, this one as a b and this one as a a, that was fine, because that will only give us the formula. Okay, here we will be able to write this as a cos theta and this as a sine x, and here we will be able to, you don't have to show everything, I'm just trying to explain you. This one we can write b by a square plus x square, this one we can write it as a sine theta, and this one cos x. So what we will be having here, we are able to make the formula of sine cos a sine b, that means sine a plus b. Okay, outside what we are doing here, we are taking under root a square plus b square in division, and we also have to do the multiplication, because randomly if we are having in hand a sine theta plus b cos theta, we cannot write in the denominator a square plus b square. So multiplication and division we are doing at the same time. We are just trying to do one arrangement, okay, which you have done in trigonometric equation, when you were simplifying it, you must have done this type of arrangement. We are just trying to make the formula. Outside under root a square plus b square is already there in multiplication. Okay. Outside under root a square plus b square is already there in multiplication. Outside under root a square plus b square is already there in multiplication. Now only I have shown you one result, that whatever we are having as an inside angle, sine of whatever is there, the output we were able to generate in between -1 to +1. Yes or no? So this sine x plus theta, whatever be the value of x, whatever be the value of theta, the output will lie in between -1 to 1 only. Okay. Here we are having a square plus b square, which we have taken by ourselves for the arrangement. Now we can say the maximum value over here. We need to multiply this in the bracket. So we will be having minus under root a square plus b square plus under root a square plus b square. Let me summarize everything what we have done. Okay, so I am trying to say, whenever we are having a format of a sine theta plus b cos theta, it will always lie in between under root negative to square plus b square. This is the formula or the rule, you can say. A sine theta b cos theta will always lie between minus under root a square plus b square to plus under root a square plus b square. How we got it? So we have done the arrangement of a sine theta b cos theta. We have tried to make the formula. Once we have made the formula, we got this. We got this part. This part we have got. Okay. This part we have got. And now in the graphical portion, we have seen that when we were taking sine 2x, sine 3x, the curve was going, it was just getting stretched, it was just getting compressed, but the output was it's same, that is -1 to +1. Okay, so sine x plus theta, it will lie in between -1 to 1. The result will lie in between -1 to 1. But under root a square plus b square also we have taken, so that we will multiply with our extreme value, and it will lie the given expression a sin theta b cos theta or a sin x b cos x, that will lie in between minus under root a square plus b square to plus a square plus b square. Okay, so from this determinant, from after solving this determinant, just focus on the determinant. Okay, we have to find the maximum value of the determinant. After solving this determinant, you will get 2 sine 2x minus cos 2x. Okay, so we can say we are having 2 sine 2x plus -1 into cos 2x. Now, whenever we can see this type of arrangement like a sine something then off, it will always be lying in the range of minus under root a square plus b square. What is our a? 2 square plus b square, that means -1 square. Okay, here we will be having this function, and other part will be square plus -1 of square. So from here we are getting 4 plus 1 under root 5, negative root 5, and there will be having positive root 5. What is the maximum value? It's positive root 5. Are you getting? Are you getting it? Yes or no? It's not clear?
Clear, ma'am.
Okay, let's move ahead. So learn this form, that whenever we are having a sin theta b cos theta form, then it will lie in the range of negative under root a square plus b square to positive under root a square plus b square. This type of question I have seen in the previous year question paper when we were having the question of range also. So directly you will be able to just say what will be the range over here. Now the next part is okay. Here only I want to add one more thing, that when we are having 2 sin x, because one more question is there which is just exactly like this only. There we have to find the minimum value. So if we are having 2 sin x, then sin x lies between -1 to +1, and if we are having 2 sin x, then the range will be -2 to +2. Okay, this is how we can find the range. If we are having 3 sin x plus pi by 6, then you know x plus pi by 6 or whatever be the angle, it will always lie between -1 to +1. If outside 3 is there, then our range will be -3 to +3. Okay, if the angle, if the question is like this, x minus 3, wait, if we are having -3 over here, just a second. If we are having 2 sin 5x, yeah, the range of this one will, it will be -1 to +1. If 2 is there outside, it will be -2 to +2. Okay, and if -3 is there after that, if after that this is -3, not equals to, this is minus. So if -3 is there, then we will be having -2 -3, then 2 -3. So our range will become -5 to -1. Yeah, can you see how we are getting the result, the maximum minimum value, so easily without doing anything? So you can use this result by solving the questions. Okay, definitely. Here also a few questions are there. I'll give those questions for practicing, and while finding dominant range, you basically the range, you can use this results. Okay, now we are having the system of equation. How can we solve the system of equation? By using Cramer's rule. Yes. So first thing, if we are having a1x plus b1y plus c1z is equals to d1, a2x, b2y, again it will happen. The same problem occur in other classes also, yes or no? Please let me know what exactly is going on. I need to check. Do you face such problem in other classes also?
No, ma'am.
Okay. So if we are having a2x, b2y, c2z is equals to d2, a3x plus b3y plus c3z is equals to d3, then we know that we can find by taking the determinant, we can make the determinant like like this: A1, A2, A3, B2, B3. This is how we can find the determinant. Now only I am going to write the rules over here. Please note it down. So first thing first, if it says the system is consistent, that means there will be solution. Now the solution can be unique solution, or it can be infinitely many solutions. And if the question says the system, then we will be using the condition of no solution. Okay, so consistent means it, the solution will be there, their solution will exist. Now the solution can be unique solution, it can be infinitely many solution, and if the system is inconsistent, that means there will be no solution. So according to the given statement, we will be using the condition. Now what is condition? So delta, this is delta. We write the determinant like this by taking the coefficient of x, y, z like this one. We can, here we will be making delta x, delta y, delta z. Now delta x will be, we will be writing, when we are writing delta x, first see how we will be writing delta x, delta y, delta z. Then I will be writing Cramer's rule over here, and you will be able to understand there that delta x will be there. So what exactly is delta x? So delta x means whatever is the x column in our delta, that we will remove, and we will take the right hand sides constant, that is d1, d2, d3 over here. So when I am going to write delta x, I will be writing d1, d2, d3. The first column, the x column, I have removed. There I have written d1, d2, d3, and the rest of the column in the delta will remain as it is. That is b1, b2, b3, c1, c2, c3. b1, b2, b3, c1, c2, c3. This is our delta x. Similarly, we will be making the first column a3, we will just keep it as it is. Y column we will remove, and that will become now d1, d2, d3. And the last column c1, c2, c3 will remain as it is. That's called delta y. What is delta z? Delta z again will be 1, a2, a3, b1, b2, b3, and the last column we will write it as d1, d2, d3 instead of the coefficient of z. So d1, d2, d3. This is how we will be writing delta x, delta y, delta z, and also delta, the determinant. Okay, now the grammar says that we can find x value from the given equation. That when we are solving the system of equation, we can find the x value by doing x into delta is equals to delta x. Delta x is what? It's just a determinant. We will be getting the value of that. Delta is what? It's just a value. It's a determinant. So from by using this condition, we can get the value of x. Delta x is the determinant, delta is the determinant. So we will be getting the value. Delta is equals to delta y. Delta y is just a determinant. Here we will be having a particular value. Delta is a determinant. We will be having a particular value, and directly we will be able to calculate the value of y from here by Cramer's rule. Delta is equals to delta z. Okay, so this is what given by Cramer's rule. Now few conditions are also given by him. The conditions are, yeah, case 1, if delta is not the given system of equation has unique solution. Now the determinant, the value of the determinant can be 0 also, right? But the first condition is when it is not 0, then and only then the unique solution. So most of the time it will be written in the question that check whether the system of equation has a unique solution, or for what value of lambda, for what value of b, for what value of c, the given system of equation has a unique solution. So that time we have to take this condition that the determinant, the delta, will not be 0. Okay. Next condition is if delta is equals to 0 and at least focus on this word delta z is non-zero, then no solution. So at least one of delta x, delta y, or delta z has to be non-zero. Then only we will be able to say that it has no solution. Okay, this is indicating the condition of no solution. Obviously there will be no solution because the rule is delta into x is equals to delta x. So if this is 0 and let's say this is a particular value is 2, maybe 3, or maybe 4, so 0 into x is equals to 4. That means 0 is equals to 4. This is invalid statement. 0 is not equals to 4. So if this type of case will arise, we will say that there will be no solution. Okay, so keep in mind this rule that when delta is 0 and at least one of the delta x, delta y, delta z is non-zero, then there will be no solution. Now the next one is if delta is 0 and delta x, delta y, delta z are 0, if all are either there will be no solution, or there will be infinite solution. Okay, so these are the three cases which we are having in hand. How we will differentiate whether there is no solution or infinite solution if delta is 0? Let's say we are having one question. Let's say we are having x plus y minus z is equals to 1. 2x minus y plus 3z is equals to 5. And x minus 2y plus 4z is equals to 4. Okay. If we are having this system of equation, then we have to check whether there will be unique solution, no solution, infinite solution, or what. First thing first, we will be finding the delta. Let's find the delta quickly. So delta will be 1, 2, 1, 1. This is negative. Let me check. Yeah. Minus 1, minus 2, minus 1, plus 3, plus 4. Yeah. This is what we are having. Let's calculate it. When we are writing the delta, we are just writing the coefficient of x, y, z. Let's do the calculation quickly. So 1, negative 4, positive 6, negative 1, cover it, 8, minus 3, minus 1, negative 4. Here we will be having positive 1. Let's see what are we getting. 6 minus 4, 2, 5. So negative 5. What are you getting? Tell me. Let me know. Let me know what are you getting from there. Are you doing it with me? So what are you getting from there as a value of the determinant? What are you getting from here? 8 minus 3 minus 1 also I had already written, it is negative 4 positive 1. Yeah. So we were getting 2 from here, we were getting 5 from here, and we were getting minus 4 plus 3. So okay, we are getting 0 over here. Can you see? When delta is equals to 0, then two cases can occur. Either there will be no solution or infinite solution, but we need to check delta x, delta y, delta z. Okay, so let's check it quickly. Let's check delta x. We will be at the place of x, we will be writing 154. The other side is having 154, we'll be writing that over here. So let's write it. We will be having 154 here. The remaining will be same, 1 minus 1 minus 2, 1 minus 1 minus 2, and the other one is negative 1, 3, 4. Negative 1, 3, 4. Please check it. What are we getting over here? The next one, the first column will remain as it is. The second, 154, negative 1, 3, 4. This is delta z will be the last column we need to change, and the first two column will remain as it is. Check it. Are we getting here also 0, here also 0, and here also 0? Check it. If all are 0, then no solution or infinite solution. You will be getting here also 0, delta y also as a 0, and delta z also as a 0. Now we just got stuck at two conditions, whether there will be no solution or there will be infinite solution. In such case, when we are having this third case, then what we will do, we will be taking any two equation from here, any two. Okay, just pick any two equation from here, and what we need to do, any two equation, let's say the first equation I have taken and the second equation. Now at the place of z, I will be taking one variable by myself, any variable. I am taking z is equals to t. Okay, so I am having x plus y minus t is equals to 1 as a first equation. So x plus y became 1 plus t. I am going to treat this t as a constant. Okay, same thing I'll be doing in the second equation. So 2x x minus y is equals to, okay, this two equation I got. Now I will be solving this two equation, this one and this one, and will be finding the value of x and y in terms of t. Okay, if we will be able to solve this two equation and we will be able to get the value of x and y, then there will be infinitely many solutions. X will be something in form of t, y will be something in form of t, and z will be t. T value, it depends upon the t value, and there will be infinitely many solutions. And if we will not be able to solve this two equation, two circled equation, after taking one of the variable as a t, any constant, we will just proceed and we will find that it is not possible to solve this two equation, because this two equation is exactly same equation maybe. Okay, it is not possible to solve, then we will say there is no solution. Okay, so this is the process of checking whether there will be no solution or infinite solution. First, we will be checking delta. If that is 0, then delta x, delta y, delta z. If all are 0, then there are two cases which can arise. One of the cases no solution, one of the cases infinite solution. And after that, we can pick any two equation, and what we can do, we can try solving it by taking one of the variable as a constant. And then if it is possible to solve, then infinitely many solution. If it is not possible to solve, then no solution. Okay, these are the three cases we are having in hand. You don't have to solve this type of thing. Everything we will not be solving in any of the question. Only in question we have to keep our eye on system is consistent, system is inconsistent, and these three parts. That is, delta is 0, then what will be the possibility? Delta not 0, then what will be the possibility? Only these parts are important. Okay. Now one concept is here. Yeah. When we are having this type of equation, that a1x plus b1y plus c1z is equals to 0, a2x plus b2y plus and a3x plus b3y plus c3z is equals to 0. When the other side is 0, this is called homogeneous equation. Okay. Here we will be having two cases only, delta not equals to 0 and delta equals to 0. When delta not equals to 0, unique solution, and when delta is equals to 0, infinite solution. That's it. Because other side is 0, 0, 0, we will not be able to make delta x, delta y, delta z. Everything will come out as a 0 only, right? So this is one of the case of, like, when we are having equation like this, that's called homogeneous equation. I will be giving the question for practicing from this portion. Okay, you will be having equation like this, and you can say it is unique solution or infinitely many solution. Let's move ahead. Now the last concept which I want to discuss over here is trivial solution. And non-trivial solution. So trivial solution means the solution will come out as a zero, non-zero solution will be having. Let me check the question. These are all the concept. Now you will be able to apply the concept for solving the questions over here.
Ma'am, can I show question?
Can I show question which is related to these topics? What you said? Please repeat. Yes, what you said? Can you please repeat? From these portions, now I'll be giving questions for practicing. If you will not be able to do, then please let me know. I'll be taking questions from these portions. Okay, how to solve the system of equation questions. Okay, I will be taking questions. Since only 1 minute is left, I will be taking questions. First, let me give question from this portion. If you have written all the